In a single throw of a die, what's the probability of obtaining an even number? Which is I prime number greater than 2. Okay, a perfect square. So problem 6. Problem what? Problem 6. In a single throw of a die. So we said that for a die, what's the sample space? Sample space is 1, 2, 3, 4, 5, and 6. 4. Okay. So n total here is 1, 2, 3, 4, 5, 6. Let me tell you. Don't write it because it is the last number. But write it because when we count, we get 1, 2, 3, 4, 5, 6. Some people may get confused and think that we have written it because it is the last number. You may have a question why they may have 1, 2, 5, 7, 10. Then you write 10 because it is 10. It is not 6 because the last number is 9, because when we count the elements inside here, it's 6. So note that. Now, this is our probability of getting an even number. So over here, we say that set of what? Even numbers. In this case, we've already spoken about even numbers. Look at this. What are the even numbers? We have 2, 4, and 6. These are the even numbers within the whole set. So n even numbers is equal to 3. I'm repeating. Number of even numbers within this, there are 3. 1, 2, 3. 1, 2, 3. So P even numbers or P event is going to be what? It's going to be number of even numbers over number total. And that will be 12. 1 over 2. Is that okay? Then it says I prime number greater than what? 2 within the set. Prime number greater than 2 within the set. So what are prime number greater than 2? Let's look at the set of prime numbers greater than 2. What are the prime numbers in the first place? The prime numbers are 2, 3, and 5. So prime numbers greater than 2 in this regard are this and that. 3 and 5. So n event, if I say n event, that means n prime numbers, what we are talking about, is 2. So P event, E means event, or E means the prime number, what we are talking about. Not even number, but it's event. So P event, or P prime numbers, will be equal to what? Will be equal to 2 over the total 6, and that will be 1 over 3. We are having a die. And die has sample space of 1, 2, 3 up to 6. So number of items within the set are 6. That is 1, 2, 3, 4, 5, 6. Then he asked us probability of getting an even number. Then we wrote the selected even numbers here. 2, 4, and 6. So how many are they? They are 3. So if you want probability of getting even number, it is 3 over the 6. And that is equal to what? Half. Then he says a prime number greater than 2. Though 2 is a prime number, but he said greater than 2. So we have 3 and 5. So 3 and 5. How many are they? They are 2. So I wrote my 2 here. The probability of getting a prime number greater than 2 is 1 over 3. Exactly. Now, there's something at the back there. Let's see. Still in your shop. So let's see. You said a perfect square. So, perfect what? Square. What are a set of perfect squares? The perfect squares here are what? 1 and 4. We've already learned about that, so if you remember perfect squares. 1 and 4. Perfect squares are numbers which have come a perfect square root. When you find so you're not getting the remainder behind it, let's say 1 point something. No. So once again, n event, if I say n event, I'm talking about n perfect squares, is 2. So P event, meaning P perfect squares, is what? 2 over a total of 6. That constitutes what? 1 over 3. Is that okay? Then it says a prime even number. When I was discussing with you, I should have told you about this one. A prime even what? Number. Prime even number, there's a particular even number. That is the only number which is also a prime number. And even number and prime number at the same time is 2. Apart from 2, will not get any even number which is also a prime again. Or that's it. So prime even number. Prime even what? Number. What is the set? It is only 2. So n event or n prime even number is equal to 1. It is only 1. This is a unit set. It is just 1. Prime even number out of the 6. So P event or P prime even number is 1 over 6, not 2. I'm repeating, it is not 2, but it is 1 because the element here is 1. So you don't write the 2, you write 1 because it's only 1 element. If there are 3, you write number of events is equal to 3. I guess I've made my point. Good. Now, we are on and on. I'm saying the problem, we are solving the problem. It is problem solving unabated. And we are still on it. So we are on problem 7. This one, let me see if you'll be able to, I will just leave it to you. But he said that if 16 identical balls in a container, numbers 1 to 16 inclusive, if a ball is to be picked at random from the container, what's the probability that the number of it is a perfect square? So you have to do it. I'm just giving you the clue. You are finding probability of what? A perfect square, which is A part. B part is a number greater than what? Greater than 10. Then a factor of 16. Okay. So what you have to do is that 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 16. After you do that, then the total number of elements in the set, n total, I am just giving the clue, will be equal to 16. 16. Then he begins to ask you these questions. Probability of getting a perfect square. So what are a perfect square within this set? 1 is one of them. 4 and 16 is them. So any event, you are expected to get 4. I'm repeating. The perfect square within that set, 8, 9, 10, up to 1, 2, is we have 4, 1, 4, 9, and 16. So there are 4. So in this case, any event, it will be equal to what? It will be equal to 4. So it will be 4 over 16. And when you work it out, you get your answer. Then he said that a number greater than what? 10. What are a number greater than 10? Starting from what? 11, 12, 13, 14, 15. You list them, then you count them. If they are 5, it will be 5 over 16. If it is 6, it is 6 over 15. If it is, you have to know them. 11, 12, 13, 14, 15. You have to count them. Then that number over 16, and that will give you your result. Then factor of 16. I'll show you how to find factors of numbers. So you should be able to know factors of 16. Okay? Why did I tell you? Factors of 16, you have 1, 2, 4, 8, and 16. So 1, 2, 4, 8, 16, which is 5. So it will be 5 over 16. Then you are on and on and on. Okay. Problem 8. A fair coin is tossed twice. What's the probability of obtaining the same outcome? A fair coin. Problem 8. Subscribe to Canadaman TV and enjoy all these tutorials free. Okay? The topic is we are on probability. Probability. The question is, a fair coin is tossed. Problem 8. A fair coin. Sometimes the projection, when they project, it may not keep too long. So when you hear, you can write it yourself and know. A fair coin is tossed twice. What is the probability of obtaining I? Same outcomes. I. At least ahead. I. Ahead. And a tail. Okay. Now, a fair coin is tossed twice. So that they can say that 2 coins are tossed once, or either 1 coin is tossed twice, or 2 coins are tossed once. So here, 1 coin is tossed, and we record So because of the tree diagram, look at how I'm going to do it. We have here to be the head and then the tail. Head top, tail down. These are like two mothers who are going to give birth to. Here is a head. This one give birth to head, tail. This one also give birth to head and tail. Since it is tossed twice, we move twice like that. That's all. If it is tossed 3 times, we move. Here we also go again. I'm repeating it. We start with head, tail. These are the mothers. The mothers, each of them will give birth to children, two children. So look at how I'm going to extract them. The arrow sign will first go this way. And to go this way. So first one is what? HH, which is comma. HH. Then we come to what? HT. We are done with Mr. H. Now we are on Mr. T. TH. TH. Then what? Then TT. This is the set of possible outcomes. So N total will be 1. This one set 1, 2, 3, 4. Okay. That is asking us question. You want P same outcomes. What is the set of same outcomes? Same outcomes. It is head, comma, tail. So N event in this case will be what? Will be 2. I'm repeating here. We count the set as 1. Same outcome. Either it is head or tail. So here N event is equal to what? Is equal to 2. Exactly. N event is equal to 2. So now that we've gotten this one, then so it means that P event or P same outcome is going to be 2 over the total 4. And that is equal to what? Half. Then it says at least ahead. So P at least ahead. P at least ahead. P at least what? Ahead. If I say at least ahead, in one of the tutorials I explained to you what an at least and at most is. So at least, that least is 1 head. Okay, the least is 1 head. So it is 1 head or more. So we have HH, which is 1 head. HT, there's a head. Then TH, there's a head. Here is 0 head, but it says at least 1 head. So TT is 0 head, so that will not be counted. So number of events NE is equal to 3. Are you getting the point? So P at least ahead will be the 3 over the total 4. Are you okay? Now, then it says a head and a tail. So what are the head and the tail? Head and what? And the tail. So what are the set of head and the tail? We have HT and then TH. I'm repeating. You see the probability of getting a head and a tail. We have HT and TH. So here once again, what is the N event? N event is equal to 2. So P events will be what? 2 over 4. And that will give you what? That will be 1 over 2. Yes, we are on problem 9. Problem 9. 3 fair coins are tossed once. Problem 9. 3 fair coins are tossed once. Problem 9. That is in your short. Read it. 3 fair coins are tossed once. What's the probability of obtaining I? Same outcomes. I. Exactly 2 heads. I. At most a tail. So here this time it says 3 fair coins. So here once again, listen to me carefully. They can say 3 fair coins are tossed once, or 1 coin is tossed 3 times, the same thing. So look at how I'm going to build my tree diagram. This time, I'm going to start it this way. Head and then what? Tail, okay? So it's like here, since it is going through some generation, it is mother, grandmother, mother and grandchildren. That's how it goes. The first one is, when it is 2, it is the mother and the children. But here, so here, I'm going to have head, tail, okay? Then here is also what? Head, tail. It's like the first one. But now, These 4 are also going to give birth. So here, I'm going to have head, tail, head, tail, head, tail, head, and then what? Tail. So look at how I'm going to extract it. I started this way. Then this branch went. Then this one also gives birth to head, tail, head, tail, head, tail, head, tail. So look at how we're going to extract it. The first arrow sign, we are on this line, watch here. We have head, then we go straight to what? Tail, comma. Then the same head. This time we come to what? Tail. So we are done with this line. Head, tail. We are here. We have head, tail. The top is what? Head, tail, head. Then we come to head, tail again. Head, tail. I'm repeating. First we move here, head, tail. First one, head, tail, straight. Head, tail, down. Tail, head, straight. Tail, head, head, tail. So now we are on Mr. T. So Mr. T, we are taking this route. So tail, head, then straight is what? Head. Then the same tail, head. We are on Mr. Tail, head. Tail, head, tail. Whatever you pick, the first one is, the third is head, second is. So here is what? Tail, head. Tail, head. Then tail. Tail. Let me go over once more quickly. Head. You go straight. Head, tail. Nearby, head, tail, straight. Head, tail, down. Nearby, tail, head, straight, which is, the straight is head. Tail, head, tail. Nearby, tail, straight is head. Tail. Now, so they can ask you to list the set of all possible outcomes. So these are the possible outcomes. So n total is equal to what? Is equal to 8. Is that okay? N total is equal to 8. So let's see the question he's asking. He says same outcomes. So same outcomes is what? It's either head, or tail. So in this case, n event or n same outcome is equal to what? It's equal to 2. So P event will be the 2 over 8, which is 1 over 4. I believe you are following how I extracted this one. Then he says exactly 2 heads. So exactly 2 what? Heads. Exactly 2 heads. Let's extract from here. Exactly 2. Here is 1. HT is 1, right? Oh, the top one is HHH, sorry. Okay. So it is HHT, then HTH, right? Then THH. These are having exactly 2 heads. Because here is 3 heads here. So it is this one is only 1 head. 2 heads, this. So this is what we are having. So n events is equal to 3. So P events is what? It's 3 over 8. Is that okay? Then it says, at most a tail. At most a tail. That is the highest is a tail. So it is either 0 tail or 1 tail. So let's start here. So HHH is part. HHH means 0 tail. So we have HHH. At most, the highest is 1 tail. So this one cannot be counted because 2 tails. 1. It says at most a tail. So, okay. Yes, HHT, 1 tail is part. Then HTH got 1 tail. This one cannot be counted because there are 2 tails. This is 1 tail. So THH. The rest, the tails are more. So number of events is equal to 4. That is, we have 1, 2, 3, 4. So, what is the probability then? What is the probability? So, P event, or P at most, a Taylor's working. So, P event is going to be what? 4 over 8. That is equal to 1 over 2. Is that okay? Now, let's move to problem 10. Problem number 10. Subscribe to Calendarman TV and enjoy all these tutorials, okay? That is, try and do that. Because we'll be solving more problems, okay? We'll be solving problems on plane geometry, trigonometry, logarithms, and all those topics that are disturbing you, the global mathematics and so on and so forth. Everything is intact, just that we are releasing them in bits, and I'm assuring you that you are safe. A fair coin is tossed with a fair die. Problem 10 in your short. A fair coin is tossed with a fair die. What's the probability of obtaining a head and an even number? Okay. So here, we are talking about a fair coin and what? He said a fair coin and a die are thrown together. So here, this is for the die. So if I do this, this is for the die, this is for the coin. Here is head, here is tail. And the die is having 1, 2, 3, 4, 5, 6, right? They have been thrown together. So here, we have H1, H2, H3, H4, H5, H6. Then here is what? T1, T2, T3, T4, T5, and then T what? 6. Look at the outcomes. So what is the N total? Total set of outcomes are what? 1, 2, 3, 4, 5, 6, 7, 8. They are 12. Total set of outcomes. Well, here is H. Here, I pick one here, like that. So probability of getting a head and an even number. So head and what? An even number. You want to get set which is having a head and an even number. We are going to have H2. Okay? H2, H4, and then H6. So an event here is going to be what? It's going to be 3. Right? So P event is going to be your 3 over 12. P event is going to be 3 over 12. Then he says a tail and a multiple of 3. So tail and what? Multiple of what? Of 3. What are the multiples of 3? A tail and a multiple. So we have T3, and then T what? 6. Okay. So an event is going to be 2. So P event will be 2 over 12, which is 1 over 6, right? Okay. So that is what we have. So P event is that, okay? So that is that.